Hi everyone, welcome to lesson 32.1, the square root method. In this video, we are going to talk about how to solve a quadratic equation of the form ax squared plus c. Normally, our quadratic equations have a x term, ax squared plus bx plus c, and we would solve this with magic x, or a quadratic formula, which is something we're going to learn in the next video. But what happens if we don't have this bx term? What's another method we can use to solve this? And so our strategy is going to be to get x by itself and then take the square root of both sides. So in this example here, I have 3x squared minus 6 equals 0. Because remember, we are looking for the x values that make our equation 0, because that's where the x-intercepts occur. So I set my equation equal to 0, and I'm trying to get x by itself. The opposite of subtracting 6 is adding 6. And I'm left with 3x squared equals 6. And then since the 3 is being multiplied to the x squared, the opposite of multiply is divide. So I divide by 3 to both sides, and I'm left with x squared is equal to 2. And then here's the new step. I don't want x squared equals, I want just x equals. And so I'm going to take the square root of both sides, because a square root undoes a square, leaving me with just x. And then my answers will be plus or minus radical 2, which means I could have positive radical 2 or negative radical 2. And here's why. If I were to square a number, let's say 3 squared, I would get 9. 3 times 3 is 9. And if I were to square negative 3 times negative 3 is also positive 9. So when we take the square root to solve, we need to make sure that we consider both options, that our value could be positive or negative. And so my answer is positive radical 2 and negative radical 2. Let's try this a couple more times. So in A, I have x squared equals 49. X is already by itself, so I am ready to square root to get rid of that square. And 49 is actually a perfect square. The square root of 49 is 7. But remember, I could have positive 7 or negative 7, because 7 squared is 49 and negative 7 squared is 49. So both of those values are my x-intercepts. In B, I have x squared, so I'm going to square root both sides to get rid of that square. 100 is a perfect square. The square root of 100 is 10, and negative 10 is also an option. In C, I have to get x squared by itself before I'm able to square root both sides. So the opposite of subtracting 10 is adding 10, which gives me x squared equals 11. And now to get rid of the square, I'm going to square root. 11 is not a perfect square, and it cannot be simplified further because no perfect squares divide 11. And so my values are the square root of 11 and negative the square root of 11. In D, in order to get x squared by itself, I'm going to divide by 2 to both sides, and I get x squared is equal to 9. In order to get rid of the square, I square root both sides, and I get that x is equal to 3 and negative 3. In E, I'm going to add 4 to both sides, and then I get x squared is equal to 4. In order to get rid of the square, I square root both sides. And 4 is a perfect square. The square root of 4 is 2, but my value could also be negative 2. In F, I'm going to subtract 2 to both sides. So I get x squared is equal to negative 2. In order to get rid of the square, I square root both sides. But please, please, please be careful. If you think about it, there is no way for a number multiplied to itself to be a negative number. Because even if both of the numbers were negative, two negatives cancel out to be a positive. So it is actually impossible to take the square root of a negative number. And you'll find out in Algebra 2 what we do with taking the square root of a negative number. But for now, we are going to say that there are no real solutions. It is impossible to take the square root of a negative number. So if you are ever taking the square root and you notice that inside your radical is negative, there are no real solutions. Let's try G. I'm going to subtract 3 to both sides to get x squared by itself. And I have x squared is equal to 0. In order to get rid of the square, I square root both sides. And the square root of 0 is just 0. There's no such thing as negative 0. So this is actually one case where there's only one solution. And so imagine where there's only one solution, only one place where the parabola crosses the x-axis. And it would look something like this. Notice how I would only have one x-intercept at 0. And then in H, I'm going to subtract 5 to both sides to get x squared by itself. And I get x squared is equal to negative 5. To get rid of the square, I square root both sides. But once again, I cannot take the square root of a negative number, so there are no real solutions. And so if you notice, there are times when I have two x-intercepts, there are times when I have just one x-intercept, and there are times when I have no x-intercepts. And here are the examples. I would say that we normally have two x-intercepts when x squared equals a positive number, such as x squared equals 49. We would take the square root of both sides. And when we take the square root, we need to consider the positive and negative values. So I would have two x-intercepts at 7 and negative 7. Then there are times when we only have one solution, and that's when x squared equals 0, because that's the only time when we only have one answer, just 0. So like we saw above, we subtract 3 and subtract 3, and if we ever get x squared equals 0, taking the square root of 0 just gives us one solution, 0. And then lastly, there are times when we have no solutions, and that's whenever x squared equals a negative number. So if I subtract something to the other side, such that x squared equals a negative number, I cannot take the square root of a negative because it's impossible for the same number being multiplied to itself to ever be a negative number. So please be mindful, you cannot take the square root of a negative, and so in that case there would be no real solutions. Let's try this a couple more times. Solve each equation using square roots. If you notice, I have x minus 5 in parentheses to the second power. So I cannot move the x or the 5 without first dealing with that square. So I'm actually going to take the square root first to get rid of that square, which will leave me with just x minus 5. But remember, whenever we are solving and take the square root, we have to consider both the positive and negative values. So x minus 5 could equal 11, or x minus 5 could equal negative 11. So make sure that we solve these twice, once for the positive and once for the negative. The opposite of subtracting 5 is adding 5. 11 plus 5 is 16. So 16 is one x-intercept. And once again, I'm going to add 5 to both sides. Negative 11 plus 5 is negative 6. And so negative 6 is another x-intercept. And I just want to show you why we have to solve this twice. I'm first going to plug in 16. (16 minus 5 is 11. And 11 squared is 121. So 16 works. Now I'm going to plug in negative 6. Negative 6 minus 5 is negative 11. And negative 11 squared, negative 11 times negative 11, is positive 121. So notice how I have to consider that inside the parentheses could be positive 11 or negative 11, because squaring both of those gives us the same value. So make sure that when you take the square root, you solve for both positive 11 and negative 11. Let's try this again. In b, once again, I have to square root first to get rid of that square. So I'm going to have 2x minus 1 equals positive radical 6, and 2x minus 1 equals negative radical 6. I cannot simplify radical 6 any further, so I just have to keep it radical 6. In order to get rid of the subtracting 1, I add 1 to both sides. So I get 2x is equal to 1 plus radical 6. And then to get rid of multiplying by 2, I divide by 2. So x is equal to 1 plus radical 6 divided by 2. And then I have to solve the other side. I add 1 again. So I have 2x equals 1 minus radical 6. And if you're wondering why I put the 1 in front both times, it's because normally when we work with radicals, the constant value goes first and the radical goes second. So if you ever have just a number and you're adding it to a radical, try to put the number first. And then to get rid of 2 times x, I'm going to divide by 2. And so I get x is equal to 1 minus radical 6 divided by 2. Let's try this one more time. I'm going to get rid of the square by taking the square root of both sides. So I have x minus 6 is equal to positive radical 2, and x minus 6 equals negative radical 2. To get rid of subtracting 6, I add 6 to both sides. So I get x equals 6 plus radical 2. That is one x-intercept. And then for the other one, I also add 6 to both sides. And I will get 6 minus radical 2 because of that minus in front. So solving these last 3 equations were very similar to the first ones we did, because every time we see a square, in order to undo a square, we take the square root of both sides. So we are going to practice doing each of those one more time. In A, I want to get x by itself, so I'm going to subtract 12 to both sides. So I get x squared is equal to 1. And then to get rid of the square, I square root both sides, and I will have x equals positive 1 and negative 1. Moving on in B, I have to square root first because I have parentheses with x minus 4 inside of an exponent. So taking the square root leaves me with x minus 4, but x minus 4 could equal positive 1, or x minus 4 could equal negative 1. So I have to solve this twice. I'm going to add 4 to either side, and so one solution is x equals 5. And the other solution is if I add 4 here, negative 1 plus 4 is positive 3. And so my solutions are 5 and 3. And then lastly, once again, I have to get x by itself. So I'm going to start by adding 6 to both sides. And I will get 3x squared is equal to 21. And then to get x squared by itself, I will divide by 3. And I get x squared is equal to 7. And to get rid of the square, I square root both sides. 7 is not a perfect square and cannot be simplified any further. So I'm going to say x equals radical 7 or negative radical 7. And that is the square root method. If we get x squared all on its own, we can get rid of the square by taking the square root of both sides. But make sure that whenever you are solving and you use the square root method, that you make your answer positive and negative, because both the positive value and its negative value, when squared, will give you the same positive value. Please let me know if you have any questions, and I will see you in class.